Introducing the new OnShape feature script, Plastic Thread. This feature script makes it easy to create mathematically accurate 3D printable threads from a cylindrical face. Simply select the face you want to thread and high-quality ANSI threads will be created instantly. Change the thread profile to ACME for higher strength threads. You can also change the number of starts or reverse thread direction to fit any project you're working on. Adding a make connector makes creating assemblies a breeze. The basic tab creates threads with a predetermined pitch designed for easy and strong printing on many 3D printers. Each tab in the feature script expands on the previous. If you would like more control over the threads, head to the Custom tab, where you can adjust the thread's pitch or TPI and thread length. You also have access to different tolerances for internal threads, meaning you can fine-tune the tolerance of the threads to fit any printer or hardware you wish to use. When combined with the original options from the Basic tab, such as adding a make connector, you can visualize the assembly before it is printed and make additional adjustments. Want to make internal threads that allow standard bolts to thread directly into the plastic without a metal insert? Create a hole the same size as the bolt and add threads with the custom pitch or TPI that match. Now you can thread a bolt directly into the part with no post-processing. In this example, two sets of holes are being threaded, one M3 by 0.5, the other 832. Using the Custom tab, the pitch and the TPI of these holes can be set and the tolerance will take care of themselves. And here's the result, a 3D printed part with threaded holes that require no post-processing. Whether you want to do a trial assembly or print a finished product, the features in the Custom tab can accommodate nearly every project. For users who want to experiment or get into the nitty-gritty of their threads, the Advanced tab gives access to several more detailed features. Use a manipulator to rotate the threads with respect to the part. This can be useful to ensure a specific orientation of two threaded parts when printed. Beyond rotating threads, you can also select how the tolerances are applied. By default, this is set to nut and bolt, meaning both internal and external threads have tolerance applied. This ensures your threads interface with any hardware you use. To customize the tolerance even more, add a custom axial or radial tolerance to increase or decrease the backlash, allowing for tighter or looser threads. This option allows for fine-tuning the tolerance to reduce or remove the need for post-processing. You can also apply the tolerance of a partially threaded stud or bolt to the shank, ensuring it fits into a matching hole. With the full feature set in the Advanced tab, any ANSI, ISO, and ACME DIN threads are possible. And with all the combinations of options, you can create threads that work for any project. To add this feature script to your OnShape toolbar, simply click the link in the description, sign in, and click the plus icon that says Custom Features at the top. Now you can use this feature anywhere in your part studios or documents. Whether you want to add a simple plastic threaded joint to a part you're working on, or thread several holes for standard bolts, the Plastic Thread feature script gives you the flexibility to add accurate and tolerant threads to any project. There are even some extra functionalities that some might find useful, such as partial cylinders. In the future, more thread profiles will be added, including square and ball screw profiles. Thanks for watching. If you have any recommendations, leave them in the comments. Also, if you try out the feature script and see any bugs, please don't hesitate to send them my way, either here in the comments or on the OnShape forum post, which you can find a link to in the description. I hope you get a lot of value out of this script. It's taken me quite a while to get to this version, so stay tuned for more updates and a walkthrough of the code. Happy printing!